الله الرحمن الرحيم. Assalamu alaikum warahmatullahi wabarakatuh. My name is Asad bin Rahman, and today I gonna talk about fluid mechanics. About what we will talk? We will talk about the definition of fluid mechanics. The second part we will talk about fluid, and also we will talk about proposal of subject of fluid, and also we will talk about flow of the fluid in the adjective. And let's start. We're gonna start with definition. What is the meaning of fluid mechanics? What is the type of fluids we will study it. What is the definition? The definition of fluid mechanics is a sub-discipline of mechanics of related of materials, is concerned mainly with fluids, which are mainly liquids and gases. It's mean the fluid it will be one from two. The first one is liquid. Liquid like what? Like water, oil, benzene, petrol, any type of these things. And gases it will be like oxygen, nitrogen, neon, any type of gas. And this specialization is study of overabundant physics behavior of substance and can be divided on the one hand into fluid static or study in the cases of inactive. It means there is two types of mechanics fluid. The first one is static, when there is no movement, or we can call it a study of an active, when the fluid is stopped without moving. And the second part, or fluid dynamics, when there is movement, or study these cases motion. There is moving, and every time it's moved, and we can call this type it's motion or dynamics. And other specialization fall under it. As we said before, there is two types of fluid mechanics. The types of studies you will be ridiculized to the static state, and the second one is animated state mechanics or dynamics. Okay, what is the first one, static one? When the fluid, gas or liquid is stopped and active. This one is the first one. Second one, animated state or dynamics one. One is the liquid or gas is moved. Dynamics, there is a movement inside of it. There is power, and that's all. Right now we will start to talk about fluid properties. There is a lot of properties we have to talk about it and a lot of details, but we will put few because it's the time of the video. But I will put some link of PDF, you can read it after that. Now we will start with Newton properties. Is a fluid has linear stress strain curve. It's like strain curve. This is because the viscosity of Newtonian fluid does not change when there is force acting on the fluid. It means if there is forcing, the viscosity it will not change. And the most important point, the viscosity of Newton fluid it will change if there is change in temperature or pressure. For example about that, water, hydrogen, gas, air, ethylic alcohol, mercury, glycerine, and also benzene. This is some example or types of Newton properties. And also I will also put link PDF down of this video. You can read it after that about much details about Newton properties. And right now we will move to the second properties, non-Newton properties. Non-Newton properties fluids are fluids with a porosity gradient that affect the viscosity coefficient. The application of force to non-Newton fluids result in viscosity without constant. It means there is no constant for the viscosity in this type of fluids. And the type of non-Newton fluids are: the first one, viscoelastic; the second one, speedoplastic; third one, thrombolic; the fourth one, thixotropic fluids. And right now we will come to some example from daily life. The first one is alcohol. It's one of it. Biodiesel, paint, ethylene, honey, cooking oil, eucalyptus oil, lubricant, spray, and dinner. This is some example from daily life. And also I will put link PDF down of this video. You can read about more if you want more details about non-Newton. Right now you will start asking me, Asad, from where I can find all these details, all this information about fluid? Can you recommend for us some books, some journals? For me, I am reading from two books. The first one is Mechanical Fluid with Bahasa Indonesia for our Dr. Boritno. And the second one, Pound Metals of Fluid Mechanics. You can find the links of PDF for these books down of this video. Or if you don't like this type of books, you can find a lot at Google and it's for free to download. Now we will move to viscosity. We'll talk about it a lot in non-Newton and Newton proposal. And what is the viscosity? Viscosity is the resistance of fluid to flow, the amount of the resistance to pressure that force to move and flow. It's like you told you how it's the liquid or gas can move inside of pipe or any stuff. It's depend on pressure, and the higher of viscosity of fluid and the lower ability for flow. The viscosity when it's high, it means need much ability to flow, a lot to move in the pipe or in the stuff. For liquids, viscosity is equivalent to the selling thermo for things. When things like honey, it will be the viscosity of it so high, and when it's smart, it will be like water. It will be the viscosity of it so less. Right now we will talk about the most important laws related to pressure and viscosity. The first one is the weight, and you can see the law in the screen. The second one is what be force, gravity, volume, high pressure. And you have one so important point. It's atmosphere. One atmosphere. If I told you one atmosphere, how many pressure it's equal? It's equal 101 kilopascal or 101.325 Pascal. And you have to focus. If he told you 76 or 760 Merkel, it's mean it's one atmosphere. You have to know like that. Now we will talk about new parts of fluid mechanics. Rotational motion. It's rotational motion around the center of the body itself. It's like to move a circle about center of the body. Same circle, same body. Unlike circular motion, in which the body mention a constant distance from the center liquid outside it. It means, as you see in in the photo, there is a center. It will move. It have same height, same distance from the center. Like you can see, D1 it will be constant, and the high one and H1 it will be stay also same. And also about the force will be same old rotation motion. We will talk about one example of rotation motion from daily life. It's like home fan. You are all of us, you know, the fan inside of our house. It's moved from same distance, same force or power, and same velocity. And in this time, the gas, it will be the fluid, it will be the gas, it will be different, and that's the most example in our daily life. And also, they said I will put for you the link video talk about how is the fluid, how does the fluid depend in the cars, and you can watch it and you will get more information about example our daily life about rotation motion. Now we will start to talk about new topics. These topics: types of flow. How is the liquid or gas flow inside of pipes? We will talk about the types of it right now. Right now we will start talk about types of flow. There is 6 types of flow. The first one, flow stable. The second one, flow unstable. The third one, unformed flow. The fourth one is non-unformed flow. The fifth one, laminar flow. The sixth one, turbulent flow. And we will start talking about everyone. And right now we will start with the first type of flow, flow stable. A fluid flow to be concentrated stable, it must be stable with respect to every possible disturbance. As you see in the photo, the shape of it, it will be same distance between every line, and it will be with the same velocity and same in the same time to arrive. It means we have one note here, it's so important. If we say delta velocity divide delta times, it will equal 0. Let's talk right now about flow unstable. Correctly is the opposite of stable. This means that there is at least one mode of disturbance with respect, which is the flow unstable, and the disturbance will therefore distort the existing force equilibrium. It means like there is force it change to flow to unstable, and it's happens sometimes when you open this for washing your hand. It's will like so fast and strong. After that it will be start normal. That's what they mean flow unstable, and you can see it at now. We can move to the third types of flow, unformed flow. Unformed flow means fluid flowing into different parts of fracture surface with equal flow velocity per unit area. It means in this thing we can say there is different surface, but the velocity is still same velocity, because it will divide per unit times per unit area. And we can take one note here. We can say delta velocity divide delta distance or delta air is will equal 0. But with the fourth one, non-uniform flow is the opposite of uniform flow. What is this one? On course of the channel, air changes, so the speed is one place is different from the others. In this type, it will be the speed is different. It's depend on the place or the surface. It's with the opposite with the first before this one. It was same speed with different area, but here the speeds will be different with different area. And we can say for one notch, the delta velocity defy delta distance or air will be not equal 0. The fifth one, linear flow. In a stream in which the particles move along paths proper to the neighbors particles. As you see in this photo, in this type of linear flow, there is some place the highest viscosity, and there is some place is 0 viscosity. It depends in which part is fast and in which part is not fast. And the last one is turbulent flow. In turbulent flow, fluid particles move in very flat or random trajectories. In this type, there is no small space. It's for free. The liquid or the gas, the fluids moving everywhere, and there is no normal types for turbulent flow as you watch in this photo. And at the end of these types or this chapter from this presentation, I will let you to know more about flow. I will put one link also is description more and more about flow down of this video, and you can read and you can take more information out. Finally, before we talk about the last topic in our video, I want all of us to pray to God forgive all the people they pass away in Samparin, Indonesia, Erlangga 402. I want to talk about Indonesian submarine. Why this is destroyed in the ocean. And before we talk about it, let's talk how it works the submarine. The submarine is depend how much deep can come down. It's depend of the tanky inside of it, and this tanky it can make the water into inside, and it will be heavy and come down of the water. And when it's want to become up, it's just wash the water from inside of it, and it will be empty. It will be air. After that, it will become up. This how it's working. The second point, and it's important, why is destroyed Erlangga 402? They say the people analyze why it's destroyed. They say Erlangga 402 can come down until 500 meters deep in the water. But it was having a problem, and it's become down more than 850 meters, and cause of pressure is destroyed. There is some submarine. It can down more than 800, but it's depend in the quality and submarine. And this is cause there is 53 person pass away last time in Indian Ocean near from Bali Island. As I said before, we have to pray for them. God forgive them. Thank you so much for listening to me. And if you have any question, you can write it down in comments, and inshallah I will answer all your questions. and I hope you will support me with like and subscribe in my channel, and see you again in new video and new topics inshallah soon.